Good morning, good afternoon, good evening, everyone. I am Max McKercher, and I am presenting a short little video on Ignas Semmelweis and his amazing hand washing theory that would later on save millions of lives during COVID, during many pandemics we've had over the centuries and soon to come. This will focus more on his life and how he made the discovery, and later on in my final draft, my final video, sorry, I'll talk more about the scientific concepts and how they relate to the 10 ideas in science. Thank you. Scientists' theories talked over the generations. For centuries, scientists have worked effortlessly to search for the truth in new and creative ways, often facing stigma and conservative backlash from society at large, even from scientists who are either too stubborn or too arrogant to investigate these findings further. Take, for example, Dr. James Allison here, and his breakthrough T-cell receptor research, which helped to produce medicine that helped the immune system to attack cancer cells with the antigen receptor protein. Through his research under the supervision of senior scientists, they even discouraged creative thinking in favor of root laboratory grinding. Even so, when he developed an efficient antibody technique by the 1990s, pharmaceutical companies first turned him away. Other visionaries like Gregor Mendel were even worse off, having less established connections and poor working material to accurately record his findings. He discovered the basic principles of genetic inheritance and lacked the connections amongst the scientific community and persuasive oral presentations, unlike other contemporaries like Charles Darwin had at the time. It took 34 years until his work on the little pea plants to be properly recognized as really the first detailed understanding of genetic inheritance. Charles Darwin, with his great groundbreaking studies on the origin of species, was widely received well amongst scientific and other academic circles, but took several decades for his theories to be even taught in schools. But today we'll primarily be focused on Ignas Semmelweis and his germ theory, which led to the discovery of using antibacterial solutions to stop the spread of bacteria. Often dubbed the saviour of mothers, Ignaz Semmelweis was a Hungarian scientist and physician who used his knowledge of hospitals and by matter of reduction to be one of the early contributors before Louis Pasteur to discover the early germ theory. Much has happened in the last 200 years after his birth, and we have him to thank for the life-changing discoveries he has made. The journey of his discovery begins in 1888 when Semmelweis was appointed first assistant of the first obstetrical clinic of the Vienna General Hospital on the 1st of July 1846. Only 2 years prior, he graduated with a Doctor of Medicine. His duties would include examining patients every morning in the preparation for his superior's rounds, supervising difficult deliveries, teaching students of obstetrics, and to be the clerk of records. The hospital was split between the General Hospital and the Maternity Clinic, where the clinic itself had two divisions, the first and the second, each headed by a professor, and beginning in 1840, medical students were only taught in the first division, whereas midwives attended births almost exclusively in the second division. Puerperal fever, also known as childbed fever, is a disease that occurs after childbirth, within the first 3 days, and progressed rapidly, causing acute symptoms of severe abdominal pain, high fever, delirium, and shock. Quite often this would result in death. Poor pregnant women all across Vienna had fears of being in severe pain in the hospital ward. There was no effective treatment for it at the time. It was here in the first division where Semmelweis observed fatalities of women in childbirth, trying to solve why there is so much drastic difference between women who caught the disease in the first division compared to the second. From his excerpts on the etiology, concept, and prophylaxis of childbed fever, we learn the conditions for the hospital, especially in the first and second divisions. He noted down that from the first time the clinic began training in June 1847, the mortality rate in the first clinic was significantly higher than the second, where only midwives were trained. In fact, the year before, in 1846, he noted down that the mortality rate in the first clinic was 5 times as great as the second. Here he shows a table persisting the contrast mortality rate of the first clinic to the second in the past 5 years. From the mortality rate in the first clinic, Semmelweis deduced that it was caused by an endemic, but as yet knew the cause. However, patients that were delivered prematurely or on the street almost never became ill, which contradicted his claim that it was an endemic cause. Patients in the first clinic were healthier, even though workers in the first clinic were no more skillful or conscientious in their duties. Upon finding the sad news that his friend and Professor Jacob Kolitschka had died, he made a vital distinction upon looking at the autopsy reports of his death. Kolitschka was a professor of forensic medicine who often conducted autopsies for legal purposes in the company of students. During one such exercise, his finger was pricked with a scalpel that was being used in the autopsy. In a few days' time, his autopsy results showed that he died of bilateral pleurisy, pericarditis, and meningitis. A few days before, he also had a metastasis formed in one eye. It was here that Semmelweis made the vital similarity between how Kolitschka had died and the cause of deaths of so many pregnant women in the first division. Maternity patients had also had lymphitis, peritonitis, and meningitis, and also a metastasis also formed in many of them, and they were practically identical to the symptoms to Kolitschka. Semmelweis rightly concluded that it wasn't the wound itself that caused Professor Kolitschka to die, but what was contaminated on the knife that he called cadaverous particles that contaminated the wound that would cause him ultimately to die. Because of the orientation of the Viennese medical school, professors, assistants, and students are frequently in contact with cadavers. These people only washed with regular soap, so of course it wouldn't remove all cadaverous particles or bacteria on the hand. He was aware of this fact because he noted that there was still a cadaverous smell that the hands would retain after washing. He deduced that if the cadaver particles are the same disease that caused both Kolitschka and the maternity patients to die, that if those particles were removed chemically, the patients contracting the childbed fever would reduce drastically. He used evidence of decomposing organic material coming in contact with living organisms, bringing on decomposition to further support his claim. He then introduced a chlorine solution that all workers had to use on their hands before entering the wards. He did this because he found that the chlorinated solution worked best to remove the putrid smell of infected autopsy tissue, and thus perhaps destroying the casual or poisonous or contaminated cadaveric agent which were hypothetically being transmitted by the material. This began in May 1847. This solution was 1 part chlorinated lime and 24 parts water, ultimately proven to be extremely effective in annihilating any bacteria or cadaver particle stench. This heavily reduced the mortality rate of women in the first division, going below the second clinic. In those 7 months of his recordings, 56 had died, roughly 3.4%, compared to the average of 9.1% rate for the past 5 years. As you see from the table above, the mortality rate dropped drastically to an average of 1.7 for the whole year of 1848. And that concludes my presentation on Ignas Semmelweis. I'd like to say this is a rough draft on my video, and I'll discuss more about what the effects of chlorines are on bacteria, the big ideas in science, and what are the effects of Semmelweis' theory today. I hope you enjoyed my presentation. Thank you so much.